Okay, so we're diving into something pretty wild today. Something that really bends the mind and maybe even breaks a few rules along the way. We're talking about the speed of light. You know, that universal speed limit that Einstein laid down, like the ultimate cosmic traffic law.
Right, the speed of light. It's not just some arbitrary number. It's baked into the very fabric of how we understand the universe.
Yeah.
It underpins so much of physics.
Exactly. And it's not just about how fast light travels, it's about cause and effect. You know, the idea that an action has to happen before its consequence.
Hmm.
That's what we call causality.
And that makes sense in our everyday experience. We hit a ball and it moves, we flip a switch and then the light turns on. But when you start talking about things moving faster than light, that whole idea of cause and effect starts to get a little wobbly.
We'll get this. A recent quantum computing experiment has seemingly done just that. They've observed something moving faster than light. And it's not some theoretical what if. This is based on actual observations, and it's causing some serious ripples in the physics world. Even Brian Cox has weighed in, calling it potentially unsettling. And, you know, when Brian Cox uses the word unsettling, it's time to pay attention.
Absolutely.
Right.
I mean, Brian Cox, he's not one to easily get rattled by theoretical possibilities. But when you start seeing experimental results that seem to defy a fundamental principle like the speed of light, it's understandable why even the most level-headed physicists would raise an eyebrow.
Yeah, I mean, the researchers themselves were completely blown away by their own findings. They're expecting to explore, you know, some of the usual quantum weirdness, like superposition and entanglement, the things quantum computers are supposed to be good at. But they stumbled upon something truly unexpected. Their first thought wasn't, oh my God, we've broken the speed of light. It was more like, oh crap, there must be a glitch in the system.
Well, that's the natural reaction, right? When you're dealing with experiments that are pushing the very boundaries of what we can measure, you're always going to be hyper aware of potential errors or instrument limitations. But the fact that they repeated the experiment multiple times and kept getting the same result, that's what makes it so intriguing. It suggests there's something genuinely new and potentially revolutionary going on.
And here's where things get even wilder. This whole faster than light thing has led some researchers to dust off a really out there concept, tachyons. You ever heard of these things?
Oh yeah, Tachyons. They're like the rock stars of theoretical physics. They're hypothetical particles that always travel faster than light.
So wait a minute. If the speed of light is supposed to be the ultimate speed limit, how can something always travel faster than that limit? It seems like a contradiction, right?
It does seem counterintuitive,
Right.
right? But that's where the theoretical physics gets really mind-bending. See, tachyons are not just particles that happen to be moving really fast.
Yeah.
They're fundamentally different. They're like particles from a mirror universe where the rules of physics are flipped.
A mirror universe with flipped physics? That sounds like something straight out of Star Trek.
Right. Well, it might not be that far-fetched. The idea is that while normal particles require more and more energy to approach the speed of light, tachyons would actually lose energy as they speed up. It's like they're on a cosmic treadmill, where the faster they run, the less energy they have to expend.
That's so bizarre. And what's even weirder is the idea that tachyons, because they break the speed of light barrier, might not even experience time in the same way we do. They could potentially be zipping around in some kind of timeless realm or even traveling backward in time.
Exactly. That's one of the most tantalizing and controversial aspects of tachyon theory. The possibility of backward time travel and the implications for causality are mind-boggling. Imagine an effect preceding its cause. It would completely rewrite our understanding of how events unfold in the universe.
It's like that old saying, which came first, the chicken or the egg, but on a cosmic scale.
Precisely. And that's why these recent experimental results are causing such a stir. If these quantum fluctuations they observed are indeed related to tachyons, it would mean that we've potentially glimpsed a phenomenon that challenges our most fundamental notions of time and causality.
I mean, some researchers have already dubbed this potential tachyonic effect the tachyon God wave generator, which sounds like something straight out of a science fiction novel. But it does capture the sense of awe and maybe even a little bit of fear that comes with the idea of potentially manipulating time itself.
Right. It's a catchy name that highlights the potential power and mystery surrounding this discovery. And if we're truly on the verge of harnessing tachyon-related phenomena, the implications are staggering. Imagine being able to send information back in time or even influence past events. The possibilities are both exhilarating and terrifying.
And it's not just the faster than light movement that's so mind-bending. There's also the observation that the quantum system seemed to respond to a command before it was given. It's like the system somehow knew what was coming in the future.
Yeah, that's another aspect of this experiment that's deeply unsettling. It raises the question of retrocausality, the idea that future events can influence the past. And if that's truly possible, it would upend our understanding of how time works.
So was this just some random fluke, a weird quirk of quantum mechanics? Or are we looking at actual evidence of the future influencing the past? Could these quantum computers somehow be tapping into information from the future, even if we don't fully understand how it's happening?
It's a question that's going to keep physicists and philosophers busy for years to come. If the future can influence the present, even in subtle ways, it suggests a universe far stranger and more interconnected than we ever imagined.
And you can bet that this kind of groundbreaking discovery isn't going to stay confined to academic labs for long. The big players, the government agencies, the space programs, the tech giants, they're all going to be scrambling to get in on this.
Absolutely. Any technology that could potentially give you a glimpse into the future or even the ability to influence past events, that's the kind of power that governments and corporations would be incredibly interested in.
Think about the strategic advantages. Imagine predicting market fluctuations, staying one step ahead of your rivals, even influencing geopolitical events. The potential for both good and bad is immense.
Right. And the ethical implications are huge. If we can manipulate time, even in small ways, who gets to decide how that power is used, and what safeguards do we need to put in place to prevent unintended consequences?
It makes you wonder if this kind of research has already been going on in secret for years. You know, those unexplained phenomena, those strange signals from space, those historical anomalies that never quite add up. Could they be the result of someone or something experimenting with these kinds of temporal technologies?
It's certainly a possibility, and if governments or other powerful entities have been working on this in secret for decades, it would mean that our understanding of the world and our place in it is far more complex than we realize.
And here's a truly chilling thought. What if we're not the only ones who figure this out? What if there are other intelligences out there, perhaps far more advanced than us, who have already mastered these temporal technologies, and maybe they're watching us? Maybe they're even influencing us in ways we can't even perceive.
That's getting into pretty speculative territory. But it does raise some profound questions about our place in the cosmos. If the ability to manipulate time is something that other civilizations have discovered, it would have huge implications for our understanding of the universe and our potential future.
And it makes you wonder, what if these recent discoveries are not just random scientific breakthroughs, but part of a larger pattern? Maybe these tachyonic effects have been influencing us for centuries, perhaps even millennia. Maybe they're the source of those ancient myths and legends, the stories of prophecies and time travelers.
It's a fascinating idea that science and mythology might not be as separate as we think. Maybe some of those ancient stories were attempts to explain phenomena that people couldn't understand with the tools of their time.
And what about the so-called Mandela effect, those shared false memories that people, like remembering a movie that never existed or a historical event happening differently than it actually did? Could those be subtle signs of the timeline being altered, perhaps, by these tachyonic disturbances?
It's a wild thought, but it does make you wonder if the past is as fixed as we think it is. Could there be ripples in time that are subtly changing our memories and perceptions?
So here we are potentially on the verge of unlocking the secrets of time itself. And it begs the question, are we ready for this kind of power? Can we handle it responsibly? Or are we opening a Pandora's box that could unravel the very fabric of reality?
It's a question that we as a species need to grapple with. The ability to manipulate time is a power unlike anything we've ever encountered before. And it's crucial that we approach it with caution and a deep understanding of the potential consequences.
And who knows, maybe the future isn't set in stone. Maybe it's something that we're actively shaping with every choice we make. Maybe the past isn't as fixed as we think. Maybe it's being subtly rewritten as we go along. But one thing's for sure, we're living in a universe far stranger and more wondrous than we ever imagined.
And the more we learn about the universe, the more we realize how much we still don't know. It's a humbling and exciting thought that there are still so many mysteries out there waiting to be uncovered.
And who knows what incredible and maybe even terrifying discoveries await us in the future. After all, if we've learned anything from this deep dive, it's that the universe is full of surprises, and some of those surprises might just rewrite everything we thought we knew about time and reality.
And sometimes those surprises might just rewrite everything we thought we knew about ourselves, too.
Well, that's a thought to ponder, isn't it? Thanks for joining us on this deep dive into the mysteries of faster-than-light travel and the potential for manipulating time itself.
It's been a fascinating journey, and it's clear that we've only just scratched the surface of what's possible in this incredible and ever-evolving universe.
Until next time, keep looking up and keep questioning everything.
And remember, the future is never truly set in stone.